So if you've watched the first video on solving these equations, I wanted to do a second run through, this time using a strategy that's known as clearing. Basically, it's a creative way of using the multiplication property of equality. You can do whatever you want to one side as long as you do it to the other side. So we can do this with both fractions and decimals. And just to kind of demonstrate it working with a simple version, let's take the problem 2 plus 3 equals 5. Not a problem, just an equation statement. Now, if I were to take these sides and multiply both sides by 10, this is what would happen. Let's see if we still get a true statement. Over here, we'd use distribution. We would get 10 times 2 or 20. We'd get 10 times 3, which is 30. And over here, 5 times 10 gets 50. So the original was true, 2 plus 3 equals 5. After we modified both sides by multiplying both sides by 10, we would get 20 plus 30 equaling 50. Still a true statement, so they both work. So this property of equality can be used in a creative way. And one of the creative ways we're going to use it is to what we do call clearing the decimals or fractions. So in this case, I'm noticing that as I work through these problems, we have a tenths place, a tenths place, and a tenths place. So what I want to do is multiply both sides by 10. So basically the reciprocal of that place value. So here's what we're going to do. I'm going to take this side and multiply by 10. And I'm going to take this side and multiply by 10. Now over here I'm doing the whole side, which means I will have to distribute. But negative 1/3, sorry about that, negative 1/3 times 10 gets 10 times bigger, which basically looks like it's moving the decimal, and turns negative 13 tenths into just negative 13. 10 times 4 tenths makes it 10 times bigger, so it looks like the decimal moves to the right, and we get now just 4x. On the other side, 5 1/10 times 10 gets 10 times bigger, and now we are just left with 51. So after multiplying both sides by 10, because every decimal value was a tenth, we have this statement. Now, before I move on, if one of these values, let's say, had been in the hundredths, let's say that this decimal was not here and it was here instead, we would have a hundredths position, okay, 2 decimals. So even if these guys were both tenths, we'd probably want to multiply both sides by 100. Otherwise, what you would do is multiply by 10 and then by 10 again to keep moving the decimal. But let's go back to our original version. We have no more decimals, so now we can solve it like we were solving before. Collect our like terms, so negative 13 minus 4 gives us negative 17x equaling 51. There's no addition or subtraction to undo, so now we'll undo the multiplication by dividing the inverse. And what we do to one side, we do to the other. Negative 17 divided by negative 17 makes a 1, and 1 times x is x. And positive divided by negative is negative. 51 divided by 17 is 3. So there's our solution. You can compare that in the last video with the process of working it with just using the decimals. Here is the fraction version. So in the fraction version, what you're going to want to do is look at all your denominators on both sides of the equation. So we've got denominators of 8, 5, and 20, and we're looking for the common denominator out of all three. And essentially what we'll do, if we look at all those multiples, 16, 24, 32, 40, and then 10, 15, 20, 25, 30, 35, 40, and then 40, you'll find that they all have a common multiple of 40. So we can use 40 as a common denominator. So our common denominator equals 40. So we're going to multiply both sides by 40. Okay, multiplying both sides by the common denominator of 40. Now on this side, we've got the group, so it's going to have to distribute. So here we're getting 40 times 1/8. 40 times 1/8. So when we work this out, we would have 40 times 1. We have 40 1/8, which gives us 40/8. And now we can think of it as a division problem. 40 divided by 8, which gives us 5. So that means now we'll get 5x. Over here we'll have 40 times 4/5. So we can do 40 times 4, which gives us 160, divided by 5. And that's going to give us 32. 160 divided by 5 is 32. So now we're going to have our converted form, no more fractions involved. Over here we'll have 40 times 1/20th. 40 1/20ths would give us 40 20ths, and 40 divided by 20 will give us 2. So now here is our new version of the equation, but this time with the fractions cleared. Okay, and again we cleared it by multiplying both sides by the common denominator of 40 in this case. And then we can go on to solve it. We have nothing to distribute. We have no like terms to collect, so we'll start by undoing the addition using subtraction. We have 2 minus 32, which gives us negative 30. And then we will divide by 5 to undo the multiplication, divide by 5, and we get x equaling negative 6 as our solution. Looking at the last two, with the distribution involved, I do find it a little bit easier to first distribute before trying to clear. So I'm going to distribute that 1/5 to give us 1/5 x plus 1/10 equaling 1/6. But now when I look at all the common denominators, we've got 5, 10, and 6. The common denominator between those three numbers of 5, 10, and 6 will be 30. So we're going to multiply both sides by 30. Now this side we will have to distribute again. We get 30 times 1/5. 30 1/5 makes 30/5. We can divide this to get 6, which will give us 6x. Over here we'll have 30 times 1/10. So we have 30 1/10, which gives us 30 tenths. And 30 divided by 10 gives us 3. And on the other side we have 30 times 1/6. 30 1/6 gives us 36. And then we divide and we get 5. So we have now cleared the fractions and we can solve this equation and still get the same solution. Nothing to distribute or collect. We're going to undo the addition. So we get 6x equaling 2. Undo the multiplication, divide by 6, divide by 6. So x equals 2/6, or you could reduce that down to 1/3. And just to go over the last problem, where you have a mixture of decimals and fractions. Again, I think the best thing to do is to always convert decimals into fractions. So we're going to go with 2/3 times the group of x plus 12/10 equaling 32/15. Now I talked about reducing this, but in this case I'm going to leave it. We're going to clear the distribute here first. So we get 2/3 x plus 2 times 12 is 24, 3 times 10 is 30, equaling 32/15. Now I'm going to look for the common denominator to clear the fractions of between 3, 30, and 15, the common denominator will be 30. So I'm going to multiply both sides by 30. So on this left side, we'll distribute. So 30 times 2/3. 32 thirds, 32s would give us 60, so we have 60 thirds. And 60 divided by 3 gives me 20. So now I'll have 20x. Here I'll have 30, 24 30ths. But I could do 30 24ths and then divide by 30. But notice that I was sort of multiplying by 30 and then dividing by 30. So in this case, these actually cancel out. They create a 1. 30 divided by 30 is a 1. And so we can get 1 times 24, and we're left with 24. And on the other side, we could do 30 times 32 and then divide by 15. Or we can start by dividing by 15 to the 30. So I'm going to do 30 divided by 15, which gives us 2. And now I can do 2 times the numerator. We have 2 32s, which gives us 64. So now we have our new version of the equation that we can solve without fractions or decimals. Minus 24 to both sides, minus 24. And I'm going to move over here. And that gives us 20x equaling 40. Divide by 20 to undo the multiplication. Divide by 20. And we get x equals 2 as our solution. So this is an alternative way to doing it. When you want to clear, I do recommend sometimes doing any distribution first and then clearing after that. Some people like to also collect like terms before clearing. Yeah, there's a lot of options, but I just wanted to provide this as an alternative method. Okay guys, see ya. Bye.